All right, hello, my wonderful student. This is part number 2 of, there we go, part number 2 of foldable number 6. This is our last foldable for 2.4. And we have a reflection over the x-axis again. So once again, this is our y-axis here, and this is our x-axis here, to show you kind of what's going on. And similar to what we were doing before in the quadratic and the absolute value, we're going to multiply the function by -1 in order to reflect it over the x-axis. So if we hear this is what our function was, so at 0, 0 times -1 is still going to be 0, so it's still going to be here. Then we have our 1 here again, which is our x-axis, and our y was 1, but now times -1 is going to be -1, or now times +1 is going to be -1. We have our 4. 4 went to 2. 2 times -1 gives us a -2. So at 4, 1, 2, 3, 4, -2. And last but not least, we have our 9. 9 went to +3. +3 times -1 gives us a -3. So at 9, we're going to go down to -3. So I'm going to go ahead and draw this really quick, and then we'll explain it. So if you turn it to the side, it kind of looks like a parabola, right? And that's kind of what it is. It's just on its side when we have our square root function. Ooh, right there. All right. So but you can see though, this is the x-axis here. You can see if we were to fold this over, it would actually be a mirror image of itself, and we can show that by showing the distance from a point to the x-axis and then to the opposite side. So if we go here, it's 1 point here, or 1 unit, and also 1 unit to there. If we go to the top one over here, it's 1, 2 units, and then 1, 2 units to the other one as well. And last but not least, we have this one is 1, 2, 3 units, and 1, 2, 3 units as well. This is 0 units and 0 units if you want to do this point as well. But that's just how that one works. And now let's go ahead and go to our last one, which is a reflection over the y-axis, which I wish we had more room on this one, but we don't. But we're just going to graph a little bit this way anyways, and we'll add some things for this. So if we look at this here, we see that the graph is actually inside, which makes things a little interesting, because whenever we have, for example, a negative number, like we do here, it's going to be kind of nice. But whenever we have a positive number, like here, it's going to make the number negative, which we know is already undefined. So the graph is actually not going to be on this side at all, because all the positive numbers here, like in the parent function, were fine. All the positive numbers that are here now on this function, where the x is negative inside the parentheses or underneath the square root value, is all going to go to undefined, because we really can't take the square root of negative unless we're using imaginary numbers, which in this case we are not. So the graph is actually not going to be on this side at all. So we're going to go ahead and start here and then move up. Okay, so at 0, square root of 0 is 0. If we multiply the 0 by -1 inside, we're still going to get 0. So the point's still going to be here. Then we're going to go ahead and go up to -1, which is here. Normally the -1 would be undefined, but we're going to multiply it by a -1 here, and making it a positive 1. Square root of +1 is 1. So at -1, +1. You know, I'm going to get my ruler and go ahead and extend this, and I'm going to write on this a little bit, but it's going to be all right, because I do what I want, I guess, you know. Hold on, let me just extend this real quick, because I do want to show where it goes to. Okay, and then just put a little bit of hash marks here. So that's 3, 4, 5, 6, 7. That should be fine enough. All right. So there we go. And we go to the next one here, which is -4. So it's 1, 2, 3, 4. And -4 normally would be undefined, but now we're multiplying by -1. So -1 times -4 gives us a +4. Square root of +4 is a 2. So we go 1, 2, 3, 4 negative, and then go up 1, 2. And then the other point would be up here. It would be at, 9, -1 times 9, -9 gives us a +9. Square root of +9 is 3. So it'd be at -9 and 3, which should be like right over there. So if we draw this graph here, oh, did I change colors? It's okay. We'd have this over here, and that would be our graph. And same thing, you can see that this is the y-axis up here. So you can see that we're actually reflecting over the y-axis, because we were to fold these two over, they would kind of line up on each other very nicely. And we're going to go ahead and show it by distance to the y-axis. So if we start in this point here, we go 1 unit to the y-axis. That means we have to go 1 unit to the other side, which we did. This one here is 1, 2, 3, 4 units here. So if we count this as 1, 2, 3, 4 units here as well, which is perfect. And this is also 9 units, and we didn't graph it all the way across, but if we did, it would also be 9 units. So that is that.